Hey, welcome back to ET Media. This is Will Henry with One Solution Group. With me today, we have our team leader, Jason Dorn, down here at the lab. Again, we're at the extrusion facility here in Manhattan, Kansas. This morning, we wanted to talk to you about proper die setup. If you notice here first, in commercial production, we usually see these type of wear rings. And they bolt onto a plate similar to what I have here, but notice all the holes are drilled into the plate. This plate here is actually for a sinking aquatic feed. The same thing stands true for pet food. Here at our facility, for the testing that we do, we like to use the insert style die. This allows us to, notice we have 10 openings here, and allows us to take these inserts and use any combination of these for specific test runs. For a couple different reasons. Number one, it gives us flexibility on our feed rates. We don't want to run at maximum capacity when we are simply researching the development of a new diet or product for a client. Number two is we are doing different shapes on a weekly basis, and we can get these made quite a bit cheaper than getting the entire wear plate made. So they offer some flexibility there. Now, as you can see, we've got 10 possible openings. If we were to fill those up, our rates would be very high. So in most cases where we're doing truly exploratory R&D, we might use as few as 2 holes, sometimes even down to 1 on highly expanded products. Most times on pet foods, depending upon the size, we run 4 to 6 inserts. So Jason, how critical is it to make sure when we're using, say, four holes or 4 inserts, how critical is the spacing in the back of this die, and for what reason are we trying to keep that in consideration for?
That's very critical. Keep even die flow to the inserts.
So what would be a common symptom we see if we do not have even die flow?
Uneven kibble, long and short kibble.
Yep. So it'll promote inconsistency. So if the holes are not oriented, like if we put 2 holes up here and 1 down here, we would have more flow of product coming out these 2 holes than we would down here. And that's where we would see maybe a longer kibble here than we would down here. So if we're only using 4 holes, what do we do with the rest of them?
We'll put a blank insert,
So we have four inserts that we're using, and then 6 inserts in the back of that die. So now it used to be quite a bit more critical that we match up our feed rate to our die open area. And we use terms like 1/4 inch per ton as a starting point. So what that means is we have a 1/4 inch, square inch of open area per ton that we expect to run in terms of feed rate. However, with our EMV, we used to have maybe a 5% process window of variability between that feed rate and open area. But with the use of an EMV, that window now goes to about 20%. So it gives us much more flexibility in the process. So what we have here is an example of an improperly set up die. We've got 5 inserts that we're using with holes and 5 blanks. And notice we've got 2 of the inserts next to each other, and it should be every other one. So we started out correctly, but we've got a little misstep right here. And again, like we said earlier, this is going to lead to this product having being longer and this product being shorter because we've got more flow over here. With that, that concludes this episode. Thanks and have a great day.